We just have a few more types of problems. So here is the rest of chapter or unit 3, chapters 4 through 6. Okay, remember we did all kinds of configurations. The orbital notation was the long one where you use the arrows. Here they have boxes. I just use lines, but you know, up and down. That's because we have 4 different quantum numbers. You know, the first quantum number is 1, 2, 3, 4. The S and the P and the D, that's the second quantum number, tells you the shape. They don't have it written here, but if you said where, you know, if you had P sub X, P sub Y, P sub Z, that would be the third one, the X, Y, Z. And the fourth is the spin. They're either going up or down. They cannot be the same. So when you're doing electron configurations, remember we have rules. We start with the lowest energy level. We start with hydrogen first, always, okay? That's Aufbau's rule. You have to fill the lowest ones first. And they just go in order. Here's your 1s with the 2, then there's 2s, and then there's 2p, and 1, 2, 3, 4, 5, 6. Remember when we do p's, we put them in one at a time. And we don't double them up till we have to. Same thing with the d's. That's Hund's rule, okay? So when you have orbitals of the same energy level, they go in one at a time, and you don't double them up until you have to, okay? And then they go in the order that I told you, like here's the 1s, this is a 2s, 2p, 3s, 3p, 4s, and then remember when you get here, it's 3d. Okay, and this is for zinc, so they have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Well, how can you tell? We'll go add these up. 2, 4, 10, 12, 18, 20, 30, and that's the atomic number of zinc, okay? So again, these are electron configurations. This is probably the more common way to do it, but these are the orbital notations. Those are the ones where you get much more information, okay? All right, so if I'm trying to find these elements, again, what I'm going to do is I can go to 3D5, I can go to the column, but it's easier just to add these up. If I go 2, 4, 10, 12, 18, 20, 25, and I look up on my periodic table, manganese, right here, number 25. I hope you can see that. Anyway, this one, same thing. I add them all up. When I add them up, I get number 50. That's tin. Okay. This one, now remember when you have the noble gas, this means everything the same as the krypton, and then you just add the row. Okay. So I would take the atomic number of krypton, which is 36, plus 2, 38, 48, 51. I don't have any idea why I did the one right next to this one, you guys. I guess just to show you the difference between how much shorter it can be. Okay, but again, if you have the noble gas, just use its atomic number and then add the rest onto it, because that's how you do a noble gas, is you take it. And I did this one's xenon, because this is a noble gas. When you do a noble gas, you can't just write Xe in parentheses and say that's it. If you have a noble gas, you have to do the noble gas above it and finish the line. But again, just add them together, okay? Here I have xenon. I take xenon, which is 54. And then plus 2, 56, plus 10, 66. And then I go find 66, and that's a weird element I never heard of before. But its symbol is dy. It's dysprosium or something like that. That's the easiest way to do it, you guys. Okay, that's how you find the elements. Add up their things, okay? These are reactions, and we use, I hope you can see this, your activity series, okay? Remember, these guys on top will replace anything below them, but they can't replace anything above them. So if I go here and I have lead plus zinc acetate, I'm going to end up with zinc plus lead acetate. So I got to look, will zinc replace lead? And I look on this little chart, and zinc is up here and lead is down here. Whoops, I can't see that, but zinc is above it. So yeah, or wait, I have lead replacing zinc. Sorry, I said that backwards. So here's lead and here's zinc. I don't know if you can see that, but zinc is above lead, so this reaction is not going to happen because lead is less reactive than zinc. Here's one where we got silver, replacing nickel. And if you look on here, or nickel replaces silver. Silver's combined over here, it's by itself. So nickel replaced it. I guess I wrote it right there, so that would make more sense, huh? Nickel replaced it. So silver is way down here and nickel is above it. So that reaction is going to happen. Okay. It will replace, since nickel is higher, it will replace anything below it. Okay. And that's how you use that chart. And again, it's just for these replacement reactions. You can do it for the anion too. In this case, We have sodium bromide and iodine. The iodine pushes out the bromine. Now the bromine's by itself and the iodine. So I look over here on my nonmetals, and iodine is the least, bromine's above it. So bromine will replace iodine because it's above it on the chart. And that's how you use the activity series chart. Again, it's just there to see if the reactions will occur. And that's it. So I will put some extra worksheets like I did with the last chapter in here as well. Make sure you study, make sure you go through your discussion questions and your assignments, your quizzes and all that, because you will see them again. Okay? That's it for this review.